Greetings. My name is Elizabeth Wade. I teach basic calculus for the mathematics department at Pellissippi State Technical Community College. This is topic 1 on limits and segment 1.2 on the existence of limits. Consider the graph shown of the function f of x. Notice that as x gets close to 2 from the left side, so the x values would be moving in this direction, the height of the function is getting closer to 4. The function would be moving in this direction, and so the values of the function would be moving closer to 4 from underneath. We call this a left-hand limit. A left-hand limit, and we write the limit as x approaches 2 with a negative sign in the exponent position. This is read the limit as x approaches 2 from the left side of the function f of x would equal 4. Notice that as x gets close to 2 from the right side, so the x values would be moving like this, approaching 2 from the right side. The function is moving in this direction, and the function values are approaching 6. We call this a right-hand limit, and we write the limit as x approaches 2, and this time we use a little plus sign in the exponent position. This is read the limit as x approaches 2 from the right of the function f of x would equal 6. So for this graph, the left-hand limit, the limit as x approaches 2 from the left is 4, and the right-hand limit, the limit as x approaches 2 from the right, is equal to 6. The values of the heights as x approaches 2 from the right and the left side of 2 do not match. We had a left-hand limit of 4 and a right-hand limit of 6. Mathematically, if the right-hand limit and the left-hand limit are not equal, then there is no limit. So we would state the limit in general as x approaches 2 of this function f of x does not exist. Notice that there's a break in the graph at x equal 2, and the limit does not exist at x equal 2. Also notice that the limit does exist for other values of x for this function. For example, if x were negative 2, and we wanted to find the limit as x approaches negative 2, then the limit would exist, and it's equal to 4. So the problem is where this break occurred in the graph in terms of limits. Let's look at the function x cubed minus 2x squared over x minus 2, which we looked at in the previous segment. Notice that as the x values get close to 2 from the left side, the function is moving in this direction and approaching 4. So the left-hand limit, the limit as x approaches 2, is equal to 4. And in a similar manner, as the x's approach 2 from the right side, the function is moving in this direction, and again the function values are approaching 4. So the right-hand limit, the limit as x approaches 2 from the right, is equal to 4. The values of the left-hand limit and the right-hand limit are the same. They're both equal to 4. Therefore, we can write that the limit in general as x approaches 2 of f of x is equal to 4. So the existence of the limit does not depend upon whether the function is defined. In this case, this function is not defined at x equal 2. Recall we have a hole in the graph at x equal 2. If you substitute 2 into the expression, you get 0 in the denominator. But yet the limit, the values of the function as x approaches 2, does exist, and these values approach 4. So the limit as x approaches 2 is equal to 4. Well, that is it for this segment. Now you need to practice this concept by working similar problems. Good luck!